Hello everyone, this is Dr. Surya. So today's problem we can see is to determine 5-day BOD of a wastewater sample. 5, 10 and 50 ml aliquots of the wastewater sample were diluted to 300 ml and incubated at 20 degrees Celsius in BOD bottles for 5 days, and the results were as follows. So a table is given for your result which denotes your wastewater volume, and they have given the initial DO and DO after 5 days, and based on the data average BOD5 of the wastewater sample is equal to. So this is a problem given. So before going into the problem, what do you mean by aliquots? So aliquots means it's a small portion. So the wastewater sample, from the wastewater sample, this aliquots, a portion of the wastewater sample, that is 5 ml, 10 ml and 50 ml, they are diluted to 300 ml. So this is, they have been diluted. So if you want to determine the average BOD, so that is what is asked in the problem. So if you want to determine the average BOD, we should know what is the BOD. Okay, so the formula for BOD is very simple, which is initial DO minus final DO into dilution factor. Okay, so if you see in the problem, initial DO is given in the problem, final DO is also given in the problem, and the unknown is going to be the dilution factor. So first thing is that we are going to determine our dilution factor. So how to determine our dilution factor? So it is going to be very simple. So the amount of water, that is final volume minus initial volume, is going to be the dilution factor. Here the final volume is 300 ml and the initial volume is going to be 5. So 300 minus 5 is equal to 60. Next is 300 by 10 is equal to 30. Next will be 300 minus 50 is equal to 6. So we have determined our dilution factor. Very simple, that is final volume divided by initial volume. Now for each and every case, so I'll take this as case 1, this is going to be the second case, and this is going to be the third case. So for each and every case we are going to determine our BOD using this formula. So for the first case, okay, so first case BOD is equal to, okay, I'll keep this as first BOD. Okay, first BOD is equal to initial DO given in the problem is, you see here, initial DO is 9.2, final DO is 6.9. So which is 9.2 minus 6.9 into, I have got the dilution factor as 60, which is equal to 138 milligram per liter. And for the second case, that is my second BOD. So for the second BOD, I am having my initial DO as 9.1, final DO as 4.4, and I have got the dilution factor as 30, which is equal to 141 milligram per liter. And for the third case, that is my third BOD. So initial DO is 8.4, final DO is 0, and I have got my dilution factor as 6, which is equal to 50.4 milligram per liter. So I have got my BOD. So what we will be doing, in order to get the average, we will be adding all the values and we will be dividing it by 3. Right. So what is its average BOD will be equal to, we have got the value is 138 plus 141 plus 50.4 divided by 3, which is equal to 109.8 milligram per liter. So if you have got your answer like this, then this is going to be wrong answer. Why it is going to be wrong answer? Because you see in the problem, in the case, the DO after 5 days is going to be 0. There is no DO at all. DO is going to be very low. So in that case, I have to discard the value of that particular BOD and I have to take my average BOD. Okay, which means my average BOD will be equal to 138 plus 141 divided by 2, which is equal to 139.5 milligram per liter, and this is going to be the correct answer. So the answer will be 139.5 milligram per liter. In order to confuse you, they might have given 109.8 or a milligram per liter in the option also. But the correct answer is 139.5 milligram per liter. If BOD3 of a wastewater sample is 75 milligram per liter and the reaction rate constant K to the base E is 0.345 per day, the amount of BOD remaining in the given sample after 10 days is dash. So this is the question here. So what is given in the problem? BOD3 is given, which means Y3 value is given to us as 75 milligram per liter. Reaction rate constant, that is my K value, is given to me as 0.345. So what they have asked is that after 10 days, that is what is the remaining amount of BOD. That is what it is asked. What is the remaining amount of BOD after 10 days? So which means I have to get the value of my Y10 as well as Y0, and since because they have asked the remaining amount, it will be going to be, the formula will be that you have to determine your ultimate BOD and as well as the BOD after 10 days, and which will be Y0 minus Y10. I hope it is understood. They have asked the remaining amount of BOD. They have not asked us to determine BOD at 10 days. You have to see the hint, that is remaining amount, BOD remaining. So which means I have to get the value of the remaining amount of BOD. Okay, so how to determine this? So first thing is that I have to get my ultimate BOD, that is my Y0 value. So that is going to be very simple. We know the formula already. That is YT is equal to Y0 into 1 minus e power minus kt. Okay, so Yt here is going to be 75, that is Y3 value is T value is going to be 3 here. So 75 is equal to Y0 into 1 minus e power minus 0.345 into 3. So the only unknown here is going to be Y0. So I will be getting my Y0 as 116.319 milligram per liter. Okay, and the same way I have to get the value of Y10. So using the same formula. So instead of T, I have to write it as 10. So which is Y10 is equal to Y0 into 1 minus e power minus k into 10. Okay, so Y10 is equal to 116.319 into 1 minus e power minus 0.345 into 10. So my Y10 value will be 112.626 milligram per liter. Okay, so I have determined the value of my ultimate BOD and what is BOD after 10 days. Now I am going to get the remaining BOD. Okay, so as such I have told remaining BOD will be after 10 days will be equal to Y0 minus Y10, that is equal to 116.319 minus 112.626, and the answer will be 3.693 milligram per liter. So this problem is solved using the logic. Suppose you want to solve it using some formula, you can use this formula also. That is Y10 is equal to Y0 e power minus kt. So which is equal to 116.319 into e power minus 0.345 into 10. Again you will be getting the same value as 3.693 milligram per liter. But the easiest way to solve is that using this you can solve it. That is the remaining BOD after 10 days is Y0 minus Y10. So the answer will be 3.693 milligram per liter. The next question is, determine the ultimate BOD of a wastewater sample which was subjected to the BOD test in which 6 ml of wastewater contains no dissolved oxygen was mixed with 294 ml of water containing 8.6 milligram per liter of DO. After incubation at 20 degrees Celsius for 5 days, the DO of the mix was 5.4 milligram per liter. The BOD rate constant to the base E K 20 degrees Celsius is 0.25 per day. So when you take this problem, the first thing they have given is for the initially for 6 ml of wastewater there is no dissolved oxygen at all. But for they are diluting it means so for 294 ml of water there is 8.6 milligram of DO. Okay. So what is understood from this is okay. So there is a 6 ml of wastewater. Okay, and in that there is no DO at all. Okay, and for 294 ml of diluted water there is going to be 8.6 milligram per liter of DO. And they have told that after incubation at 20 degrees Celsius for 5 days, the DO of the mix was 5.4 milligram per liter, which means they have given our final DO value. Okay, final DO is 5.4 milligram per liter. And they have asked us to determine the ultimate BOD, that is going to be our Y0. So what is our Y0? This is the formula. So usually if you have this, if you want to determine the value of your ultimate BOD, we have the same concept or same formula, that is Yt is equal to Y0 into 1 minus E power minus Kt. So this is the formula generally we use to determine our ultimate BOD. But if you take here, I should know the value of T value is going to be 5 days because they have given 5 days incubation. So T value is 5 days. So if T value is 5 days, first I have to get the value of my Y5. So only if I get the value of Y5, I can determine the value of my ultimate BOD. Okay, how to determine the ultimate BOD? It is very simple because they have given the dissolved oxygen value or DO value is given. So in the previous problem also we have seen which is my BOD phi, or BOD phi is equal to initial DO minus final DO into dilution factor. Okay, so if you take in this problem, final DO is already given as 5.4 milligram per liter. Okay, so my aim is to determine what is the initial BOD as well as dilution factor. So dilution factor we can determine it off very easily, which is final volume by initial volume. Okay, that is my dilution factor. So initial volume it is going to be 6 ml. Final volume is 294 plus 6 divided by 6. So which is 300 by 6. It is going to be my dilution factor. That is my diluted factor will be equal to, dilution factor is going to be 50. Now the next step is I have determined the value of dilution factor. I know the value of final BO. So only thing I have to get the value of initial DO. So in order to get the initial DO of mix, there is a formula that is also known to you earlier, which is DO of wastewater into volume of wastewater plus DO of diluted water into volume of that diluted water, the whole divided by total volume. Okay, so what is my initial DO? That is 0. No dissolved oxygen is present and that particular volume is 6 plus diluted water will be 8.6 into 294 and the total volume will be 6 plus 294. So which means my initial DO is equal to 8.428 milligram per liter. Okay, now it is easier for me to determine my BOD phi or Y phi. So which is equal to DO, initial DO minus final DO into dilution factor. So initial DO I have determined as 8.428. Final DO is 5.4, which is already given in the problem, and dilution factor I have determined as 50. So my Y5 value is going to be 151.4 milligram per liter. Now it is easier for me to determine my ultimate BOD using the formula Yt is equal to Y0 into 1 minus e power minus Kt. So here T is going to be 5. So Y5 value is 151.4 into Y0 into 1 minus e power. K value is given in the problem as 0.25 and T is going to be 5. Okay, so my Y0 value is going to be 212 milligram per liter. So the answer for this particular problem is Y0 is equal to 212 milligram per liter. Thank you and happy learning.